Hello friends, today we'll learn about the Kehui T906 cable for locator equipment. So this is the front display of T906 cable for locator, where you have 4 buttons and a rotating knob where you can select the distance to fault or the total end of the line. So switch on, switch off, set 0 and then press test to trigger the pulse. So now you have a display where it gives the complete information for the user what they need. So you have all the options available here so that it is easy for you to identify the different kinds of fault in different modes. So you have a mode option which gives you access for different modes to test the cable, whether it is TDR mode, ICM mode, MIM mode or DK mode. So you can, whenever we use the equipment to locate the distance, most of the people use MIM mode or SIM mode. We also call it as arc reflection mode. For the pinpointing, we use ICM mode. So if you go to the range option, you can see that the equipment has different ranges for different length of the cable. You can select based on the cable length, whether it is 500 meters, 1 kilometer, 2, 4, 6, 16, 32, 64 kilometers. Go to adjust. You can see that you can adjust different gains. You can increase or decrease so that you can see the clear distance to fault. We have a 200-meter cable here, so the fault is open. It is showing the open waveform. So based on the insulation of the cable, you can set the different VOP so that you can accurately find the distance to fault. So the distance here, our cable is 200 meters. So based on the insulation in the cable, we set the accuracy to 200 meters by fixing the velocity of propagation. Okay, and you have a balance. If the curve is imbalanced, you can make it balance. Then go to wave. You have two options like zoom in and zoom out. If you want to zoom in, zoom more, you can zoom more, or you can zoom out. You can restore these files and also you can save it in the memory, and then later compare it when you trigger the pulse for your next testing. And you can compare the different waveforms in this. Go to 5. So whenever you take a waveform, you test it. As you press test, it gives you the waveform. Go to save. It asks you to save it. So then later you can save the file. So once the files are saved, if you want to view those files, go to view option and then you can select whichever file you need and see what's happening. Display. So it will give you all different kinds of waveforms what you have recorded earlier. If you want to delete this file, you can delete it, or if you want to copy all those files, you can transfer it either directly to the pen drive or transfer it in your PC. Set option is also available where you can set the date, time and other options in the equipment. I hope this video gives you more information to understand the T906 cable fault locator. Hello friends, now you can see some demonstration. We will demonstrate on different distance of cable faults and show you how the open circuit and short circuit fault occur and can be identified using T906 cable fault locator. So first of all, when you switch on, we will make sure that we are using in a TDR mode, and then based on your distance of the cable or the total length of the cable, will select a different range. So now my cable length is 200 meters, so I keep it as 500 meters and mode in TDR. So now I'll adjust my VOP based on the insulation of the cable so that I get an accurate location or accurate distance of the cable. So based on the insulation of the cable, my VOP is 157 meters per microsecond. So now let's increase the gain so that I can see the total end of the line. Go to adjust, increase the gain so that you can see the end of the line as a open circuit. So this is our end of the line. So what I do here, I just press test and I get the distance to the fault. Now I create a short circuit fault at the end of the line and we will see how our graph will reflect. I have made a short circuit there and then I press test. You can see that the curve has been changed, showing it as a short circuit fault at the end of the line. So we go to file, we save it and we record it. Similarly, if you want to see that at different distances, what we can do, we can just create a short circuit fault in between the cable and see what's happening. I go to wave, go to memorize, then I compare, then I press test. You can see that the distance has been changed to a different fault location as I created the fault at the different distance. So the fault distance is 138 meters. Now I create an open circuit fault at 138 meters and you can see that it will change to open circuit now. You see, this is how you can identify the open circuit faults and the short circuit faults. If you want to adjust the gain little bit lower so that you can see clear graph, you can do that. Then you go to file and save. So if you want to see the previous files, you can just go to below and you can just display it. You can see different files which are been recorded earlier. It's simple to use and very user friendly. So if you want to compare some files, you can go to compare and see that what's happening. So you can see two different files which gives an information about the fault distance comparing what's happening in the cable. So this is open circuit fault and a short circuit fault. Go to file, select some other file, display, this is the line, then go to wave and compare, and you can see that the end of the line is 200 meter open circuit and the fault has been created at the 138 meters. So you can rotate the cursor and you can see where exactly it's 142.5 meters. So my VOP is 159 so that you can get the accurate distance. Let's see the VOP at 159 and you can see that the distance is 139 meters accuracy. So if you don't set the proper VOP, you need to see plus or minus from the distance. So if you know your VOP exactly, it will accurately locate you to the accurate location of the fault. So I hope you get the clear information about the equipment, how to use it. Thank you very much.